Okay. Öncelikle herkese merhaba. Ben Enes. Burada İslam'la beraber size Udemy'nin Elasticsearch güncelleme macerasından bahsedeceğiz. 5. versiyondan, yani versiyon 5'ten versiyon 7'ye nasıl upgrade ettiğimizden bahsedeceğiz. Sunumumuz İngilizce olacak. Hello everyone, today we will talk about Udemy's Elasticsearch upgrade journey. How we upgraded from version 5 to 7. I'm here with Issam, my colleague. We are both software engineers at Udemy. Who are we? What do we do? We are at the search platform team at Udemy. Our job is to manage and improve the search infrastructure of the Udemy. We work on Elasticsearch clusters. We manage and improve them. And we also build some tools and services around Elasticsearch for our engineers to use them easily. To give you a bit of context about Elasticsearch, Elasticsearch is a distributed search and analytics engine. It's very fast, and its distributed nature makes it horizontally scalable. And you can perform very complex queries and aggregations against Elasticsearch, and that's why it's widely used across the industry. It's provided by the Elastic company. The way they provide Elasticsearch is that you can use most of the features in a free license, and some advanced features are provided in the paid license only. It's built on an open source information retrieval tool called Apache Lucene. It's built in Java, and it's also used for this building search infrastructures across the industry. And the way you use Elasticsearch is that you install it on machines, multiple machines, and each of these machines are called nodes. And these nodes come together in a cluster. And in those clusters, you have the data in indices, and each index is kind of like an abstraction of SQL table. And those indices are divided in shards, and those shards are distributed in these nodes, so you can execute parallel search in a very fast fashion. And those shards are replicated, so in case one of the nodes in your cluster is going down, you will still be able to serve. Okay, to give you a bit more context about our search infrastructure, we will take a look at that. We have 3 environments. We have a production environment, which is serving the users, taking the user traffic. We have a disaster recovery environment, which is a mirror to the production, and we always have almost the same data as the production in disaster recovery. And we have a small development environment where our engineers use to develop new features. We have 3 Elasticsearch clusters in production and also in disaster recovery, which is a mirror to that, as I mentioned. And we have a main cluster, which is a search-heavy cluster. It's taking 27 million requests per day, and it has the user-facing indices and mission-critical stuff in there. We have that. And we have an indexing-heavy cluster, which we call the auxiliary cluster. It doesn't have much traffic. It has only 1/3 of the search-heavy the main cluster's traffic, but the indexing load is very high. And also we have a log storage cluster. It's a small one compared to the others, and it has like stuff like payment transaction logs and some historical data. And in Udemy, we have a mixed architecture. Our core web applications runs on a monolith. It's a huge code base. And along with that, we have some services. We move some of the functionality from our core application to those services. Services are built in Kotlin. And for the search infrastructure, we have 3 services. First is a core search service, which serves the search results when you type a, let's say, search query to the search bar in the Udemy website. So when you go to the Udemy and type like guitar courses, the course search service is used. We have an indexing service which we use to monitor, rate limit our indexing, real-time and bulk indexing to Elasticsearch. It reads from Kafka, it consumes from Kafka and writes that, let's say, bulk indexing records to the Elasticsearch. And we also have a utility service for periodic health checks, such as replica checks, checking if an index has a replica or not. So if an index does not have a replica, you will lose its data in case of a failure. And it also, the utility service also does periodic snapshots. It takes the snapshot of the production periodically for all clusters, and it restores them back in the disaster recovery environment. And we also have a data pipelines, and those data pipelines runs on AWS, and it reads from various data warehouses such as Hive, Presto, Redshift, and we do some complex analytics in there from the row tables, put them in the data warehouses, and from there we put those data in Elasticsearch in bulk indexing fashion. By the way, indexing means inserting data. It's an abstraction in Elasticsearch, which represents inserting data in Elasticsearch. So some statistics: we have 400 average requests per second to all of our clusters, and it is 35 million requests per day. And at peak traffic, we had 1,200 requests per second. This was early 2020. And we have, like, in production environment, we have 21 nodes, 11 in the main cluster, 7 in the auxiliary cluster, and 3 in the log storage cluster. And we also have other nodes, other clusters in other environments, so it gets up to 50 to 60 nodes. We have 450 million unique documents in 25 indices, but all of those indices are replicated. They have either 1 or 2 replicas. That means we have up to billions of documents. And we have 7 cross-functional teams using Elasticsearch for building great features. And they use it for analytics, they use it for search, and they use it for putting logs. And we, excuse me, we have software engineers, data engineers, and some data scientists in those teams. Okay, here's a diagram for our search infrastructure. We have the monolith in the center. It queries the Elasticsearch clusters through a reverse proxy, which is HA proxy. And the monolith queries the core search service for getting the search results in the main page. And we have real-time and bulk indexing going through Kafka to indexing service to Elasticsearch. We also have the data pipelines. Also, like, the monolith is connected to data warehouses and some SQL databases, and it writes the data in there and it reads from there. We also have the data pipelines reading from these data warehouses and does the bulk indexing. Like, it publishes the bulk indexing jobs to Kafka, and from the Kafka we read and write. We read the jobs in the indexing service and write into Elasticsearch clusters. And we also have the utility service for periodic checks and snapshot restores connected to Elasticsearch. Our services are running in Kubernetes. They're written in Kotlin. Yeah, it's pretty much that, I guess. But we had some problems, like, let's say, shortcomings with this, with our infrastructure and with our systems. First one is we had no access control to indices, which means, like, anybody in the organization could go and query the Elasticsearch or do whatever they want, like perform whatever query they want against the Elasticsearch, which included deletion of documents or even indices. So it would allow unpleasant mistakes. Your baby intern would go and delete an index and blow up the production, which is not very funny. So and this would cause some trust issues. We need to handle because like we don't have any mechanism for access control, we needed to handle all of the indices in Elasticsearch. We couldn't give any ownership to teams about that. We couldn't use, because we were in the Elasticsearch 5, we couldn't use all of the Elasticsearch features in services, because Elasticsearch 5 high-level Java client doesn't allow you to use, like, it's not complete in the sense that it doesn't allow you to use all of the queries and cluster-specific services. So because we want to gradually move more functionality into services, this was very important to use all Elasticsearch features in the clients. We had no transport security between nodes. We had no secure connection to Elasticsearch. The connection to Elasticsearch was happening through HTTP. And these two meant we had some security flaws, let's say. And we couldn't keep up with the potential increase in search traffic. Yeah, people started to stay at home since the beginning of the global pandemic, and that would mean a rise in traffic for us. So we wanted to meet the demand for that. We want to have scalable. We want to have a scalable architecture and have enough capacity to handle the traffic that would bring us. And to address those shortcomings, we had two main objectives when we started our journey. We wanted to unlock new features by upgrading Elasticsearch, unlocking security features and features in clients, as I mentioned. And we wanted to have better cluster topologies to keep up with the demand, to be able to handle the traffic. Our goals by doing that was modernizing our infrastructure. We wanted to have, as I mentioned, we want to have a complete set of features in clients, Elasticsearch clients, both in Python and Java clients. We wanted to establish security while in between nodes. We wanted to establish TLS in inter-cluster communication, and we wanted to connect to our clusters through HTTPS, both for the developers in the company and for the applications connecting to Elasticsearch. But we wanted to be on a long-term support version of an Elasticsearch. We didn't want the Elastic guys to come and say, just upgrade your cluster to that version after 2 months. And we wanted to manage access control to indices. As I mentioned, we had trust issues, and we wanted to solve those trust issues to give ownership of Elasticsearch indices to our stakeholder teams. So we decided to have, like, we wanted to be on a long-term support version. So that's why we decided to be on 7.8. But we needed some requirements. Like, we had some constraints doing that. We could only we couldn't allow any downtime in user-facing functionality. We couldn't just put an announcement to serve the Udemy is out of service for 1 hour or something. So it should be seamless. But luckily for us, we could allow bulk indexing jobs to stop for a day, because our bulk indexing jobs are not mission critical. So we could allow that. We cannot allow loss of data in the new clusters. So everything in the, all of your favorite Python courses in the previous cluster should be in the new clusters. There should be smooth transition in the code base. We couldn't, so we don't want it to affect the existing functionality. We just wanted to change the underlying infrastructure, let's say, for the beginning. And we needed to complete 1 month before the Black Friday to allow load tests and high availability tests. Because we wanted, in the Black Friday, as some of you know, we get high traffic, and we cannot do much changes during the Black Friday. So we needed to finish this job before the Black Friday, 1 month before the Black Friday, to see if our clusters are at the capacity we want. And if something fails, can we react to that? Or how does our clusters will respond to that? So we checked alternatives for that. One of them was the rolling upgrade. The rolling upgrade is changing version of a node at a time in your cluster. So for example, you have 3 nodes. You change the version of the first node, and you move to the other, and you move to the other. And during the upgrade, you have different versions in your cluster. But it's only possible in minor version upgrades. So if you're upgrading from 5.6 to 5.7, that's okay. But for the major versions, you can only do it for one major version at a time. So if you're upgrading from 5 to 6 or 6 to 8, that's fine. But we wanted to upgrade two major versions at once, because we also because there are some changes in Elasticsearch major versions, and we didn't want to go through them twice. We just wanted to adjust our clusters once, and we also wanted to change the topology of our infrastructure, our clusters. So we wanted to have them at once. So that meant we need new clusters. Now Issam will talk about how we prepared our test clusters for the Elasticsearch 7.
Okay, thanks, Enes. And hopefully you are still listening to us. And now we are going to say how we started. So the first thing that we started with is spinning up a new cluster. And that should be the way to go, is about to think how we could have a new cluster with a new topology and how we should test it. And based on that, we decided to spin up the new cluster with some changes to the topology. We already had a good topology in terms of the node size and the node numbers, but we want also to have more, let's say, performance advantage over how we are doing our queries, and at the same time having some way to guardrail our clusters on some heavy loads. So we introduced the coordinator nodes. And these coordinator nodes is kind of let's say, of a smart load balancer that perform scatter and gather operations for the Elasticsearch based on the type of queries. As you know, Elasticsearch is a distributed environment. So you need a kind of a way to find your data among all the nodes, then gather it in the proper way and send it back to the client. So the coordinator node was really good on this. Taking away the burden of from the data nodes, and that also from the distributed nature, you don't want the data nodes to lead these efforts, and it's good to take off that kind of operations to the coordinator node. And also the good thing about coordinators node, it's more aware about the cluster internals, which are the nodes that holding the main shards of that index, and which node is the master, so you don't route that much of traffic to that. And this is the difference between the regular load balancer that we usually have and having coordinated nodes. So that was the way to introduce that based also on our requirements. Next, then on the preparing, we said, okay, we are going to spin up a new cluster, and we already in Udemy embracing, let's say, the ideology of having an automated infrastructure and automated configuration. So we don't come and say let's provision a new cluster or new nodes manually. So we use Terraform to do infrastructure as a code to handle all this stuff through also an automated pipeline, and we use Ansible to run the configuration on the nodes. And we get benefit from Elasticsearch custom Ansible rule, and we build up on the top of that Ansible rule. Why we build up on the top of that Ansible rule? Because we want to have an abstraction that allow anyone just to say I want a new node, and this node should be a data, a master, or a coordinator node, and that's it. So we hide all kind of settings and configuration that we need to set for the nodes, because we usually have the same configuration for all our clusters. And from then, we thought yeah, let's start moving some data. And here was the surprising things, and Anas will talk about it later. But we started by moving the data that we have on the development. And yeah, that's worked. It allowed the people to test, but we will see how things go. So another purpose of doing spinning up the new cluster and moving the data, it was testing and checking all the breaking changes. We want to make sure before we go to production or before we are enabling also the teams, we want to make sure that at least we address the major changes. And by that, let's bring up some of these changes, single type in an index, no parent-child relation, and also we split indices with multiple types. So we want to make sure that all the indices are like doesn't have multiple types. That's one thing, and doesn't have any relation inside it, and also split whatever indices that we had. And also that's bring another challenge, like not all the templates that we have can work with ES7. The good thing in Udemy also, like we always have, let's say like we put all our code and also like configuration in a way that can be accessed to anyone, and also like it can be automated. So for example, we have these indices, and we have like a kind of modeling for these indices as a templates, and it's exists in a repo, and everyone to want to do any change, these like changes go through like some testing, and also it will be applied automatically on our clusters. So we said like we don't want to break these changes. So what we did, we kept the current templates, the current indices and models that we have, and we made a conversion tool that can change these templates from ES5 to ES7, and it can be automated. Then we like we spin up the new cluster, and we start asking like the teams to do like some data quality measures. And we had some troubles because like we can do like snapshot from like different major versions. So we had like to do like remote indexing, and that was okay in the dev environment, but not that the best like on the production. And we faced some issues that we also like know how like to fix it, is about like the head counts, filtering, Boolean fields, and query coordination. Okay. So I think like that's your part, Enes, as well here.
Okay. We had like after the test cluster is done, we had to come up with a plan for production. We need to start by provisioning new clusters with new topologies, and we need to move the data from previous clusters to next ones. And we need to update the Elasticsearch clients, because there has been some breaking changes between the clients about queries and response parsing, let's say. So in provisioning new production clusters, we put coordination nodes in front of the clients, in front of the master data nodes. So that would allow us to distribute the scatter-gather load in new nodes. So the master and data nodes would only need to handle the queries, and the coordination nodes would take much of the burden from them to gather up responses from different nodes and putting it back to the clients. So we wanted to put reverse proxies to distribute queries among these coordination nodes as well. And after we provisioned the new production clusters, we need to move the data in the old-fashioned, like in the same fashion as we did for the testing clusters. We just did the remote cross-cluster, let's say, reindexing. It's a method for moving the data between Elasticsearch clusters. And we needed to update the code base. We needed to update the Elasticsearch clients in services. This was fairly easy. We would only need to update Java clients in services, and there was not much changes. And it was easy for the core search service. But for the indexing service, we needed to make it work for the old bulk job formats as well. So if you are sending an Elasticsearch 5 bulk job in the old format, this would still work for our new indexing service, the updated indexing service. We did that for being error-proof, let's say. For data pipelines, there was not much change, again, because all the indexing was going through the indexing service. I mean, all the indexing was produced into Kafka, and the indexing service was consuming that. But because the indexing service was very error-proof, we didn't have like much changes in data pipelines. The monolith is whole another story. We have like hundreds of thousands of lines of code in the monolith, and we have like many teams working on that. So we needed to coordinate all of the efforts. For that, we created a base branch where we put all of the commits for the client upgrade, and we sync that branch to a development container for the teams to check if their functionality is working at that stage of the work. We opted on using the old Python client. We were using the 5.4 client, and we wanted to continue using that. We didn't want to change to 7 because that would come with a lot of changes in the code. And the good thing about Python is you don't have to, it's very dynamic in nature. So you don't have to change, you don't have to break things. We needed only to change the response parsing in the client, and that everything would work. We had global flags to switch between Elasticsearch 5 and 7. So during the upgrade time, in case something bad happens, we could immediately go back to Elasticsearch 5, and the user will not notice anything. And all of the, we thought all of the monolith was using our Elasticsearch integration library for accessing Elasticsearch. So in the base branch, we put Elasticsearch integration library changes first, and told the teams to change their code using our new version of Elasticsearch integration. So we had some utility functions such as get doc type. As we mentioned, there are you can only have a single type in an index in Elasticsearch 7. It was giving you the right doc type based on the Elasticsearch version. I mean, based on the global flag. So if the global flag is on the Elasticsearch 7, have this document type, and if it is on Elasticsearch 5, have this document type. And we put a lot of ifs in our code base, like if Elasticsearch 7, do that query, if Elasticsearch 5, do that query, but it would work with both. So we had sessions for checking the functionality with all of our 7 teams using that at the end of the code base update on the monolith. And all went fine. And the last week, we noticed that our analyzers in Elasticsearch 5 is not working in Elasticsearch 7 as we expect them to be. The analyzers are kind of like NLP pipelines, analyzing your text to have better search. You have stemmers, synonym filters, and some character filters and stuff like that in the analyzers. And the thing is, our analyzers, the filters in our analyzers was not working in the same order as in Elasticsearch 5. So the synonyms was working before the stemmer, or the other way around in Elasticsearch 7. So that affected the search ranking. That affected the results appearing in the search results. And we had gone through a bit of struggle with that, and we had to come with a new order with our token filters and char filters. And the day before, we stopped all of the bulk indexing jobs. We moved most of the data since the day before, and we had to sync our data to the new cluster periodically. In order to do that, we wrote a script, and it would work every 2-3 hours. And based on the last updated times of the documents, it would update the new clusters. It would move the newly updated documents to the new clusters. But we miscalculated one thing. We miscalculated an index. We thought an index would be ready in time, and we had only 2 days for moving that index to the new cluster. But turns out it takes more than that. It's the message threads. It's the communication channel for instructors to students, and the index was very large. It was 500 gigabytes, and it was going to take more than 4 days maybe. So in order to do that, we need to move the index in more indices, and for each indices we needed to have more shards that would come up with let's say more parallelization. So the indexing process has gone very fast when we did that. So we could be able to, like, it was a last minute change, but we were able to make it in time. So in the exit, we woke up very early in the 8 a.m. We kept our fingers crossed. We freeze releases, no changes in the code base, that means. And we informed our site reliability folks. We deployed the course search service. The course search service was okay to use some old data, the data from the day before. That was fine for us. And then we synced the data like that. The updates happened before until the last sync. And we stopped real-time updates from the indexing service. The good thing about the indexing service is that you can stop consuming from Kafka. So the real-time updates will be kept in the Kafka. They will not be consumed. And we had a final data syncs. That means all of the data in the Elasticsearch 5 were now in Elasticsearch 7. And we made the global switch. We were checking data log for the Elasticsearch health dashboards and live actions per minute tails. We were checking if there were going to be any errors. And boom, errors start to appear. We needed to, when you have error rates around 0.1%, that's fine. But if they get more than 3 or 5%, you have some problems. That means we had to switch back to Elasticsearch 5. And then, of course, we needed to start real-time updates. And we found the causing queries, let's say. Some of the queries in our monolith, in our huge code base, was not using our Elasticsearch library. That was a surprise to us. And we found a constant in the depth of our code base, which was called the price levels. And it was using 0 and 1 to filter Boolean fields in Elasticsearch, where you need to use false entry in Elasticsearch 7. That was a surprise to us. And we did some hot fixes in 1 hour to that isolated queries. And we stopped real-time, and we decided to switch to Elasticsearch 7 again. We stopped real-time updates, we switched to Elasticsearch 7, and there were no more errors. Yeah. We deployed the new indexing service, and it started to write these real-time updates to Elasticsearch 7. So it was 1 minute for each change. We didn't reflect the real-time updates. And we started releases. People were doing new changes to codes, and we informed our site reliability folks. And the time when we were doing the hot fixes, the updates went to the Elasticsearch 5. So we need to make a final sync to move that data. So only for maybe 5 to 10 minutes, that data was kept in the old cluster. So we moved that back. And we enabled all bulk indexing jobs and periodic backups. So we will have our disaster recovery environment available. Okay, we had our clusters ready. So we needed to load test our clusters to see if they're up to the capacity we want. We made some preparations for the game days. We used Locust, an open source HTTP load generator. It's written in Python. It's actually using events and lightweight threads. So it's very fast. It can go up to hundreds, thousands of requests per worker. We created a set of queries used in the Elasticsearch, and we mimicked the actions per minute rates. So for the top queries, we get for these queries, I mean. For the top queries, we curated those, and we mimicked the APM frequencies for those. And we added 2 new nodes to our indexing heavy, the auxiliary cluster, because since the switch, its CPU usage was increased. So we thought like we need more nodes in Elasticsearch 7 for that cluster. In the game day 1, we tested our search heavy cluster, and we could go up to 1.4 times the maximum traffic we had. And at 1.4 times, we saw the error rates and latency started to increase. And that was because the very high CPU usage on our 2 coordinator nodes. We had like 7 data nodes and 2 coordinator nodes, and those coordinators nodes was kind of like the bottleneck for us. So in the 1.4 times the max traffic, we had 85 to 90% CPU usage in our coordinator nodes, and where the CPU usage in master and data nodes was around 50% in average. So we decided to add more coordinator nodes, and we added 2 more coordinator nodes. In the game day 2, we tested our indexing heavy cluster. It doesn't take a lot of queries. It takes only 1/3 of the main cluster. And we could go up to 5 times maximum traffic in the early 2020 easily. And all of the CPU usage was fine in all of the nodes. It was around 50 to 60%. And in the game day 3, we tested our main cluster with our new nodes. So right now we have like 4 coordinator nodes with 7 data nodes, and we could go up to 3 times the max traffic. That was fine for us because we would only like having to go up to 3 times maximum traffic was enough for us. And as you can see, the CPU levels for the coordinator nodes is around 30%. And the CPU levels in average for the data nodes is around 60%. And we had some high availability tests to make sure in case something bad happens during the Black Friday, we can react and the cluster will be fine. We tested removing a node from our clusters, and all of the clusters was fine because our indices were replicated. But when you remove 2 nodes at the same time, the clusters would not allow that. The clusters would go red. So we will work on that later. Yeah, and we tried adding a new node and adding a coordinator node because we automated everything in infrastructure as code and in Ansible. We could add a node in 10 minutes. And for the data nodes, we can add a node in 10 minutes, but having the cluster moving shards from other nodes to that node takes like 1 hour. For coordinator nodes, because they are stateless, it takes instantly. It happens instantly. Issam, can you talk about the conclusion and future plans?
Thank you, Enes. And let me add to what they said usually, like about software development. It's really hard to name, and it's also like to manage the cache, and also it's hard to manage the timing for presentations. But we did it. And in the conclusion, it was like a great team effort of 3 people, me and Enes and Ibrahim, our engineering manager. And we find out, like, we want to share some findings that it's really great to have an automated way to provision and configure your nodes. And also you should build something that is reliable for the infrastructure, and that is going through only having good testing at every level, from unit testing, integration testing, even data testing, A to B testing or experimentation testing, and infrastructure level testing. Also, we unlocked more features for Elasticsearch clients. So our customers, when I say customer, our other teammates, the developers, can also build more powerful application with easier way. And the next step that we unlocked is the security. So right now we have more access control. We can enable auditing and a lot of stuff along the side with these upgrades. For our future plans, we are setting up the access control plan in play with the teams and the application. We are going to secure our end-to-end communication through HTTPS. Also, right now we already like have a central like Kibana instances for the clusters and Cerebro for like monitoring, and also we had reverse proxy for services, which is under testing right now. Also, it was really great like to test how powerful is our clusters, and as you saw, like the results was about like we totally understand like how to add more nodes and how we need to optimize the sharding inside like our clusters to have a better indexing and searching latency. And yeah, that's it. And guys, like please join us on Udemy. Like if you want to join like a company that is like mission driven and you want to make other human lives like much better, just join us in Udemy. Go to udemy.com/careers and we will be happy to see you there. Okay, that was on time.
Hello again, Issam and Enes. It was a great presentation for all of us. Thank you very much for your contribution to Developer Summit 2020. And we have a few questions. If you have time, I would like to ask you.
Yeah, sure.
Okay.
Thank you for allowing us.
Thank you. The first one is, could MongoDB be an alternative of Elasticsearch by using as a searching database from Murat?
Sam, do you want to answer that?
Let's say like MongoDB is very great database that can also scale in a good way, but our main problem here is like full text search, and I'm not sure. I don't know like how good is like MongoDB in full text search, but compared like Elasticsearch is one of the best like solution overall the world. So I guess like yeah, that could be something, but right now the thing that is really trending is Elasticsearch for full text search and Algolia for managed search as well.
Thank you for the answer. And the second and the last question from Uğur. Could we use Reindex API for moving the new clustered Elasticsearch?
Yeah, like we use the Reindex API to move data from our old clusters to the new one, because Elasticsearch allows you to have like cross-cluster reindex. So you can reindex from the remote cluster. Yeah.
Thank you.